Hey guys, welcome to U-Sub Day 2. We did some of these yesterday, just a real brief introduction to U-Substitution. Today we're going to do a little bit more of the trickier ones, but let's first get started with a refresher of how do we do a U-Substitution. U-Substitution is what we do when we need to do the reverse of the chain rule. So when I see a problem like this, I am first looking for something that I can establish as U, and then I can also take the derivative of it, and that's nearby. So I see that we have secant x tangent x in parentheses, but I don't really want to take the derivative of that. That looks gross. I'm going to have to use product rule. Nasty. Let's look at secant x. Okay, let's say I said let u equals secant x. Well, if u was equal to secant x, what would be the derivative of u? Well, the derivative of u would be secant x tangent x with respect to x. So now I have my derivative of u, secant x tangent x, so I can rewrite my integral. Oh, that is, there we go. So we're going to rewrite this. Well, u is secant x, so that's going to take care of this one. Du is secant x tangent x, which takes care of that one. So I don't know why this is here. This guy just appeared out of, you know what, forget it. It's there. Okay. Secant x tangent x. I'm going to rewrite this one as u du. Oh, well, there you go. That's all of it. So if I integrate u du, that is u squared over 2 plus c. So that means this is secant squared x over 2 plus c, because u was secant x in the first place. All right, let's try another one. Let's see. Oh, well, this one's interesting. I'm not seeing a derivative anywhere of anything that I could make for a u, but I see that I have x squared plus 1 in parentheses, so that's about as close as I'm going to get to a u. So let's see something. Let's try. Let u equals x squared plus 1. That means du equals 2x dx. Well, I don't see a 2x dx. I have an x dx in my original integral, but I don't have this 2 right here. So what could I do with that? So what I can do, I need to somehow get rid of that. So I'm going to multiply both sides by 1/2. And let's see what happens. So 1/2 du is, oh, well, that becomes x dx. Now x dx matches what I have in the original integral. So now instead of just rewriting it with a du like I normally do, no pun intended on that one, I promise, I'm going to rewrite it with 1/2. So let's go over here. Let's do the rewrite. Let's say, okay, so x squared plus 1 squared, that one is u, but now instead of du, I'm going to have a 1/2 du. All of this stuff is still multiplied, so really this is just like having u times 1/2 times du. But this is a really kind of gross format, so I'm going to take this 1/2, since it's a constant multiple, I'm going to bring it out to the front. I'm going to say 1/2 the integral of u du, and oh, some of you already caught this. I forgot the square. It was there the whole time, guys, I promise. Okay, so now I've got 1/2 the integral of u squared du, which I can integrate. The integral of u squared is u cubed over 3 plus c multiplied by 1/2, so I'm going to have, that's too much, oh well, u cubed over 6 plus c, but I want it in terms of x. U was originally x squared plus 1, so I've got x squared plus 1 cubed over 6 plus c is my final answer. Okay, I think that one kind of blew some of your minds. Let's look at another one. Ooh, integral of the square root of 2x minus 1 dx. I'm going to think of this as the integral of 2x minus 1 to the 1/2 with respect to x. Well, that's still not helping. Can I integrate like normal? No, I got the 2x minus 1 inside the square root. So it's got to be a u substitution. All right, let's say u is equal to 2x minus 1, which means du is equal to 2 dx. Great. I have an extra 2 hanging around that I don't have up here anywhere. So instead, I'm going to multiply both sides of du by 1/2 to cancel out the 2 here, and then I simply just have dx, which takes care of the dx right here. So now I'll go to the rewrite process. I'm going to say the integral of u to the 1/2. Now I know I'm going to put 1/2 du, and the last time the 1/2 just moved out front. I'm just going to do that now. So now I have 1/2 the integral of u squared du. So I've rewritten everything in terms of u that was originally in terms of x. So now I integrate like normal. 1/2 2u to the 3/2 over 3. Oopsie. Plus c. 2u to the 3/2 over 6 plus c. Wait a minute. Why did I do that? Mervin, that was silly. The 1/2 and the 2 cancel, so it just becomes u to the 3/2 over 3 plus c. Okay, still not done. Gotta have this in terms of x. Nope, u is 2x minus 1, so this is now 2x minus 1 to the 3/2 over 3 plus c. Basically, what is happening here is we are doing a u substitution, but when we do said u substitution, the exact derivative of our u is not apparent in the integral. So what we do instead is we somehow modify du to where it does match, where it does perfectly replace what we had in the original integral. Okay, I know this is still a little scary, so let's try another one. I want you to pause the video and give it a try on your own. Again, check your work, see how I did it, see how you did it, see if it matches, and then we'll reconvene. So hopefully you actually paused it and didn't just wait for me to pause. But you know, it's cool. It's whatever. Let's see. U is going to be, the derivative of sine is cosine. The derivative of cosine is negative sine, but there's no negative. Ooh, but sine has a squared on it. I feel like because that one is squared, maybe I should make that one my u. Let's try it. U equals sine of 3x, because this whole thing, I'm thinking I can put this in as u squared here in a little bit. So the derivative of u is going to be 3 cosine 3x according to the chain rule. Oh, look, there's cosine 3x, and then dx on the end. But again, I have this extra 3, so I'm just going to move it to the du as a 1/3. du equals cosine 3x dx. Okay, so let's see. Do I have everything accounted for? Am I ready to rewrite? Let's see. U squared would be sine squared 3x. du is going to take care of cosine 3x dx. Well, I guess if I have 1/3 du, it will take care of that. So let's rewrite. We're going to have 1/3 the integral of u squared du. So all that crazy nonsense turns into 1/3 the integral of u squared du. So I have 1/3 u cubed over 3 plus c, which turns into u cubed over 9 plus c, which turns into the sine of 3x cubed over 9 plus c. At any point, if you wanted to check your work, you could always go back and take the derivative using the chain rule. That will always get you back, well, it should always get you back to what you started with inside your integral. And if not, you've done something wrong, go back and check it again. So we're going to pause here for now. I'm going to have another video here in a minute on how to do a U substitution with a definite integral. So far all we've done is indefinite. Now we are going to switch gears and do the definite integral.